Right, so today I'm going to discuss the cross product. Now, let's have, again, for example, we have two vectors. So this is now the first one, V, and this is the second one, U. So previously, I show you that when you look at one of them, for example, U, it has two components. The first one is the one that is parallel to V. Let me call it U parallel. And then the second one is the component that is perpendicular with V. So this is U perpendicular. Now, previously, I already explained that the dot product is basically the multiplication between these parallel components. So in this case, what you will get is actually when you do a dot product between U and V, that's the magnitude of U times the magnitude of V times, okay, for example, now we have an angle here between U and V. So let's call it theta. So this is now times cosine theta. But again, the dot product actually only produce a scalar. So that's not a vector. So that's the product. Now, the second multiplication that we can have is called cross product. So this is now U cross V. Now, essentially, this is the multiplication between the perpendicular components. So in this case, we have now the magnitude of U perpendicular times the magnitude of V. So what is now the magnitude of this perpendicular vector? If we have an angle here and also the length of U, so this is the length of U, therefore, we know from, trigonometry that the component perpendicular here is the magnitude of U times sine theta, and then times the magnitude of V. So essentially, when you do a cross product, what you will get is now, the multiplication of the magnitude of U times the magnitude of V times sine theta. So that's quite similar, but be careful. The dot product is cosine and the cross product used sine. So, but this is the thing. When you do a cross product, what happens is this cross product will produce a vector. So that's the difference between the dot product. If you have a dot product that gives you a scalar, but cross product gives you a vector. Now remember, when you talk about vector, actually this is a quantity that has two things. So it has a magnitude and also it has a direction. So we have the magnitude here already, which is the magnitude of vector U times the magnitude of vector V times sine theta. But how can we get the direction of U cross V? Now, actually, there is a nice simple rule. It's called right hand grip rule. So basically, this tells us how we can determine the direction of a cross product. So for example, when now again, you have these two vectors, V and then U, and then now you want to get the direction of U cross V, right? You want to get the direction of U cross V. So essentially, when you now look at your right hand. So what happened is the four fingers here, first of all, they are pointing to the first vector. So now you can do this actually now, put these fingers pointing to direction of U. And then after that, you will now rotate this finger, the shortest rotation to the second one. So this is the rotation that you will do. Now, when you actually use your right hand and then trying to rotate from U to V, the direction of the thumb here, the direction of the thumb is actually the direction of that cross product. So in this case, when you do a cross product of U cross V, it is pointing into the page, into the paper. So it's going into the screen, it's going into the paper, it's going into the page. And we have a notation for it when you want to say something going into. So this is how we write it, using a small circle and then just put a cross in it. Yeah, so this is just to say we have a direction pointing into the page or pointing into the paper. Now be careful when you have now V cross U, yeah. So what happened is now when you first do the direction, your four fingers here, they are actually pointing to the first vector here. Now you are actually pointing those fingers to V, and then you rotate to the second one, you rotate to U vector. So when you do now this movement, so first of all, you go to V, and then after that you rotate to U. The direction of your thumb is actually now going outward. So it is pointing outside the page or the paper. So the thumb is going towards you, actually, to our direction. Now, there's a notation actually to say that something going outside the page, something going outside from the page. So we will write like this using a circle, and then there is a small dot in the middle. So that's just to say this is outside the page, and this one is inside. Now, now, so that's how we get the direction, okay? So let's now use an example. So let's suppose I have the same vectors u, v here. And then I want to do now the cross product between them. So what is now u cross v? Well, of course, you can get its magnitude, because we can get the magnitude of u, we can get the magnitude of v, and then you can also get the angle between them before we have done that, and then you just put those numbers into the formula that you had before, the magnitude of u times the magnitude of v times sine theta. But remember, again, this is just to calculate the magnitude, okay, the magnitude of u cross v. Now, there is another way actually doing this, yeah, when you have now these two vectors. Yeah, essentially, we will now write them with their unit vectors first. So in this case, u is now 1i plus 2j and then plus 4k. And also v is now 2i plus 5j and then plus 8k. Now look at this. When you now do a cross product between them, it's like what we did before. Essentially, you can multiply them algebraically, you know. So in this case, we will now do this multiplication. I know probably when you already learn about this, you will think, why don't we use Sar's method? I'll go with that later after this, but I just want to give you the basic idea first, okay? Yeah. So essentially we have three terms here, and also we have another three terms. So when you multiply them, you will get nine terms, right? Now let's see the first one, yeah. So basically that's from this cross product with that. So let's do this now. 1i cross 2i. So what is that? Now number, you can just multiply it with number. 1 times 2 is 2. And then we have now I cross I. That's the first one. Now what is the second one? That's from 1i and then cross 5j. So again, 1 times 5, it's 5. And then I cross j. Next up, 1i cross 8k. So 8i cross k. So these are from this guy multiplied by all of this, yes? Now we have now the next one, which is 2j cross 2i. So let's write here 2 times 2, that's 4 actually. So 4j cross I. Next, 2j cross 5j, so 10j cross j. And then 2j cross 8k, so 16j cross k. And we will now do the next one, which is between this 4k and 2i. So what is that? 8k cross I plus 20k cross j, and then plus 32k cross k. So as I said before, we will have 9 terms. You see 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, probably you wonder, what are these? You know, I cross I cross j, I cross k, and so on. Okay, let me now show you, yes? So, essentially, when you have now the unit vectors, the cross product between unit vectors, you know, for example, I cross I. Now, let me tell you now. Essentially, when you do the cross product between unit vectors, this is what happens. So you know the magnitude of the cross product will be the magnitude of these vectors. So in this case, 1 times 1 times sine the angle between them. Now, if you have these two guys where they are actually the same unit vectors, yes? So essentially, they are pointing to the same direction, right? And therefore, the angle between them is 0. Now, you know, sine 0, it's 0. So essentially what I'm showing you here is I cross I, it's 0. And that's also the same thing as J cross J, that's also 0. And also K cross K, that's also 0. So essentially, these guys, they will disappear. So they are 0 because of that, you know. I cross I is 0, and then J cross J is 0, and then K cross K is 0, yes? Now, what are the others? You know, for example, I cross J. Now be careful, I cross J is not 0, because when you're trying to calculate the magnitude of this, yeah, I cross J, essentially that's 1 times 1 times sine. Now, this is I, the unit vector pointing to the x direction, and then this is J, the unit vector pointing to the y direction. So you know that the angle between them is actually 90 degrees. So this is sine 90. Yes, and you know sine 90, it's 1. So I cross J is essentially 1. But there is one more thing we need to find out. This is the direction of I cross J. So essentially now you are using the same right hand grip rule. And when you do right hand grip rule, therefore the thumb is now pointing to this direction. And that's actually the direction of Z. That's actually giving you now this guy, this unit vector K. So what I'm showing you here is actually the I cross J is giving you a vector, and that's a unit vector k. So this is very important actually when you now do cross product between these two unit vectors, I cross j, it's giving you k. Now you can do the other cross product, for example, j cross k. Yeah, when you do this, essentially the magnitude is equal to 1, right? But then when you think about the direction using right-hand grip rule, this is now going to the I direction. So essentially what you see here is I cross j giving you k, j cross k giving you I. Now, probably if you don't want to go too much complicated with the right-hand grip rule, there's a diagram actually. There's a diagram that makes it easier to remember. So I'm now making ijk into this diagram. Yeah, so they are now going counterclockwise. Now, you know what happens is when you do I cross j, that's giving you k. When you do j cross k, that's giving you I. When you do k cross I, that's giving you j. That's basically what this diagram tells us. Okay? I cross j, it's k, and then j cross k, it's I, and then k cross I is j. Now, let me tell you another thing, actually, from this diagram. So this basically giving you positive unit vectors, yeah, plus k plus I plus j. Now, if you go now clockwise direction, if you go clockwise direction, now instead of I cross j, we go now j cross I. Now what happens is you will get this guy, but it will be a negative, so minus k. Okay, so j cross I is a minus k. So this is important actually when you have two vectors and then you do a cross product between them. Yeah. Now, if you swap the order, basically that's giving you another vector which is the opposite direction of the first one. Okay. So now when I do k cross j from this diagram, that's giving you this guy now, but it is a negative. And lastly, when I do in this case, so what's left now? I cross k. Yes, I cross k. That's actually giving you minus j. So, I think this diagram is quite nice because that tells you how to get the others. Now, let me just bring the previous calculation first. Yes. So essentially we have these guys, and you already saw before that three of them disappear. Yeah. Now, if you remember what we just discussed before, I cross j, it's k now, it's k. So what we have here is now 5k. Now, what is I cross k? Okay, let me just draw another diagram like this. I cross k, but you go, clockwise direction. That's giving you a minus. Now, it is minus j. And then next up, j cross I. J cross I is also clockwise direction. So this guy now, what is j cross I? That's minus k. And then this one, 16. J cross k. Now j cross k is clockwise direction. So that's I. And then this one, 8. What is k cross I? K cross I, you go counterclockwise, yes? So that's positive j. And lastly, 20, k cross j. K cross j, that's minus I. Now, you see what happens is when you do now the cross product between u and v like this, from 9 terms, you end up with 6. You have 6. So there are 6 actually. And you know what happens is 3 of them, you add them, yeah, and then after that you subtract. So let's calculate this now. 16i, and then minus 20i. 16i minus 20i, that's minus 4i. And then this one we have 8j, and then here we have minus 8j, so that's actually 0j, or just ignore that. So this is 0 essentially, right? And lastly 5k minus 4k, so that's minus k. So that's actually the result. This is the result, guys. When you multiply u cross v, you will have a vector minus 4i plus 0j minus k. Or if you want to write like this now, that's fine. Yes, minus 401. Now I know some of you probably already saw that there is a shortcut to do a cross product. Yeah, now I'm going to show you now. Yes, so you know what happened is when you have two vectors like before, and then you do the cross product. Yeah, yeah, I think doing this calculation is quite not practical, because perhaps you will forget what I cross j, j cross I, and so on. So there is actually a better way to do this. But you know, the reason I'm showing you this is because I want you to see what happens when you have I cross I cross j, j cross j, j cross I, and so on. Okay, that's important. Now, at the end, of course, if you have now two vectors, and then you want to do the cross product between them, yeah? So let me now write again these vectors, 1i plus 2j plus 4k, and then the second one is 2i, and then plus 5j plus 8k, yes? So now when I do the cross product between u cross v, what I'm gonna do first, I will create so-called a matrix. Matrix. So matrix is just some arrangement of number or objects, you know. In this case, we have now the top row, which are the unit vectors, I, j, k. And then the second row below it is the components of the first vector, which is 1, 2, and then 4. Okay, 1, 2, and 4. So now you write like this, yes? And then after that, the row below that is the second vector, 2, 5, 8. So essentially, we have a matrix that the dimension, the size is 3 by 3. Y is 3 rows times 3 columns. So that's the size of the matrix, okay? 3 by 3. Now, the method that I'm going to show you is called Sarus method, Sarus method. So essentially, this is just a general method. In this case, we use it to calculate the cross product, but you can also use Sarus method to calculate the determinant later. Yeah, we will do that later. So how do we do the Sarus method? Well, first of all, you need to copy the first two columns. In this case, ij, and then 1, 2 to 5. Now, what I'm gonna do, I will draw some diagonals here, and then what I'm gonna do, I will now, okay, so we still have some diagonals also here. We will now multiply the components in each diagonal. So in this one, for example, I times 2 times 8. So that's 16i, yes? And then plus, so with the reds, you add them. So what is next? J times 4 times 2. So 8j. And next, k times 1 times 5, 5k. So that's what you get from these red diagonals, yes? Now, what about the other diagonals, the blue? So essentially, when you have this direction, what you do is to subtract, yeah, to subtract. Subtract with what? Now, let's see the first one. 2 times 2 times k, that's 4k. Next up, minus what? 5 times 4 times I, so that's 20i. And lastly, minus what? 8 times 1 times j, so 8j. So now that's the Sarus method that we get, okay, the calculation that we get. Now you see what we will get is 16i minus 20i. So 16i minus 20i, so that's minus 4i. And then 8j minus 8j, that's 0 again, yeah, that's 0. And lastly, 5k minus 4k, that's 1. Okay, so essentially we got the same thing. Remember, we got, what was that? So minus 4, 0, 1. Minus 4, 0, 1. So that's the same vector like what we got before. Now at the end, when you do the cross product, yeah, essentially, this is the method that we will use in the future. It's called Saros method, yeah. But I think it's good to know the basic idea when you do the cross product, which is essentially the same thing like algebraic multiplication, but then you need to remember what you will have when you have I cross J, J cross K, and so on. Okay. So I think that's for today. Yes. Right.